Hello, today I am going to discuss about the bilinear search. It's a new searching algorithm and it's a variation of the linear search. So linear search basically is a simple searching algorithm which is search an element in an array by comparing one by one in a unidirectional or in a one direction way, but for the bilinear search it is compared like in the both ways, both direction, and so it takes less time and less comparison with the element. So let's know about the bilinear search. Bilinear search, as you can see it's not available here, so I implemented so this is a totally research oriented thing. And if I go to this paper, so here you can see the bilinear search. So this is a bidirectional linear search algorithm and its comparative analysis with linear search algorithm. So searching is a process for checking and finding an element from a list of elements. So there are like linear search and there are the bidirectional linear search. For the bidirectional linear search, this is the algorithm. Like let's take one linear array which is in elements, and the algorithm search for element x, and p is the present of the location of the element x, like p is the index. So after that the algorithm returns p equals 0 or false if the element x or the searchable element which is given input by the user is not present in the array, and otherwise p equal to 1 if the x is present in the array. So if x belongs to a or 0, if x does not belongs to a, input you take a array a value x to be searched, and in total like the size of the array. After that in step 1 it will initialize I equal to 1 and step 2 j equal to n. So mainly this these are the steps where you assign the values to start the searching from both direction. And this p equal to 0 is assume that the element is not present in the array. After that while I less than j, it enters like if the forward index is lesser than the backward index. So in this case it will check if li not equal to x and lj not equal to x. Like if the element of the forward and backward direction is not equal to x, then we will increase the I by 1 and j and decrease j by the 1. So like it will coming for increasing in the back forward way and decreasing from the backward way and assigning p equal to 0. And if any of the condition will be false, then if equal to then we assign p equal to 1 and return the value, and if equal 1 then return the 1 and else return 0. So that's the basic algorithm for searching an element using bilinear search. And I make a live coding so in Python, so you can so I can test this algorithm, is it true or not. So for this, if I take a large amount of large size of array, so in this case it will perform very well, like it will give me the result very quick. So basically this is the bilinear search algorithm. So for your concern, I print the value of I and j, so you can see the values live, so slash in and not found if it is not found. So after that, this is the function body where the same as take the input and the array, and this is a length of the this is the length of an thing that it is the. So if I print the like past 100 elements, so you can see the, and rather than 0 I search for like 243. So let's start the algorithm. So if I start the algorithm, so as you can see that now it's run for quite of speed, and after after a while it found the element in search space very quickly. But if I try this algorithm rather than bilinear search, only using linear search, then the speed will be really decreased. So let's take a look at the linear search. So for linear search I do the same thing here, and for I in R, if I equal x, return true, and it will break the loop. So that's a basic linear search. Let's take the same element and same array for the time comparison. So I fix a iteration counter, so I count the iteration with, so iteration equal to 0, and while it will increase by 1. So it will iterate. I think it's unended. So now it will find. Let's format the document. Now it will totally indent, and here I also take an iter counter. So and it will print the iter counter or by linear search. And here also I print the iteration required for linear search. So let's take a competition between the bilinear search and the linear search. I think here is some error. Now take a look. I again do the same wrong iter. So basically iter is a function where it will make a thing iterable. So as you can see that for the bilinear search it will only take the 23,194 search. I think I need to print it before of it. Print iteration for linear search. So now if I run it, as you can see it is hugely improved. For the randomly shuffled element it will for the bilinear search it only takes 29,742 iterations to search a element, where the linear search takes 70,257 iterations to search element in the search space. So it's drastically reduced the search time and search space for the element, and I think bilinear search is a good algorithm to search some element. And that's all for today, and thank you very much for hearing me